Hello everyone, it's Friday. Today we're going to be working on Unit 5, page 12. It is factoring binomials number 2. We're going to be starting off the same way that we did yesterday, factoring some binomials using the area model. But then our objective for today is to actually transition to factoring without using an area model. But first, go ahead and start our DIN question, the review and the preview. To remind yourself of what we did yesterday and then start thinking about how we could do that same thing but without an area model. So go ahead and pause that video here for me and then come back. Alrighty, I actually went ahead and started our DIN on my key page here. And we have our area model all set up with the binomial that they gave us, 36x plus 48. It's kind of going to be the answer in our area model. Okay, remember we're working backwards. And then we want to find that GCF. So just like we did yesterday, I started setting up some of those factorizations. Some factors of 36 are 1 and 36, 2 times 18, 3 times 12, 6 times 6. Okay, those all would equal that 36. And then I did the same thing for 48. 1 times 48, 2 times 24, 4 times 12, or 6 times 8. And our next step is to circle our greatest common factor. What is the biggest number that these two share? It has to be on both sides. It could be 1, that's pretty small. Could be 2. It could be even 6. Or I'm seeing here we both have a 12. So I think that's our greatest common factor. And that's what we'll be using on the left side of our area model. And then if you think back to yesterday one more time on how we fill in the top of our area model, it is using those other factors. Okay, 12 was multiplied by 3 to get that 36. So we need that 3 here. And we're also going to need an x. Okay, so that 12 times 3x equals 36x exactly. We're going to put our plus sign in the middle, and then we're going to do the same thing with the 48. We needed a 4 times 12 to get to 48. So we have to put that same 4 over here. And that is our new product of the GCF and a new binomial that when multiplied will equal the binomial that they gave us. Okay, so that is our answer for the DIN review. Now the preview is asking us to just think and write down any ideas we might have about these two questions. What operation are we using when we factor? And then could we factor without an area model? What might it look like? I'm going to go ahead and write some ideas down. And we're not really going to have a final answer for this preview, but these ideas are going to help us throughout our notes today to actually learn how to factor without that area model. And so what operation are we using when we factor? It's kind of multiplication because factoring involves two numbers that can be multiplied to get an expression. So if you put multiplication, there's one idea. But then we're also kind of dividing because we're doing that multiplication backwards. So we have the 36 already, and then we find that 12. And even though we already had 12 times 3 equals 36, if we didn't have that list, we could take that 36 divided by the GCF and get that new binomial. So if you put division, that's also an operation here that we're using. And then I'm actually going to leave this part of our preview blank we're going to learn some of the steps for factoring without an area model. We're actually going to see what that looks like throughout our next exercise. So let's go down to exercise 1, and just part A is telling us to factor how we already know how to factor. Use that area model one more time so that we can see what happens with this 18 and 27. So at this point, you guys should be able to do this part on your own. I'm just going to kind of put it on my screen so we have it to reference. We're starting with our 18x and 27. If I have those factors, the greatest common factor that you would find should be 9 times 2 and 9 times 3, where we would use that 9 as our GCF. Then we'd have the 2 on top here with an x to make 18x when we multiply, and the 3 on top here to make 27 when we multiply by that 9 again. Adding in the middle, and this is our new product, 9 times that new binomial. But part B wants us to show that math just a little bit differently. They're asking us to fill in the blanks of the equivalent expression here using the same math that we did in the area model. Okay, so the same multiplication that we're using, we're just filling it in a different way. So 18x plus 27 equals, that's our original expression. They labeled the 2 spaces where our GCF should go. So that's going to be our 9 here and our 9 here. And we're going to use these other parts of our new answer to fill in the other blanks, okay? We got that 18x by doing 9 times 2x. And then we got that 27 to add by doing 9 times 3. Okay, so this is showing our multiplication, that operation that we're doing, just in a different way without using that box method. And lastly, part C, this is actually how we began to write our answers yesterday. That 9, that GCF, is happening twice. We could actually kind of combine things, put it on the outside, and keep our 2x plus 3 together. And then if we were trying to go back to that 18x plus 27, that's where we could use our distributive property. And we'd still be multiplying that 9 twice, but we show it once. Okay. And so now we're going to practice a couple of these binomials, and we're still going to have to find our GCF. But instead of using our box method, we're going to try to write it in these 2 ways. Okay. B is kind of how we could write the step 1. After we find that GCF, we'll fill in what we need to multiply for both. And then C is the form that we're going to leave our answers in. Okay, as a product of 1 GCF and then a new binomial. So let's go ahead and move down here. We have lots of examples. I'm actually going to go ahead and just give myself a little bit more space between these. We're going to do all 4 of these together, and then I'll move you guys on to the practice independently. So our hint here says we're still finding our GCF first. So let's go ahead and do that. We have 12 and we have our negative 15. I remember negatives from yesterday are just a little bit different. And the reason why we have that negative 15 is because it's like we're adding a negative instead of subtracting. We're going to go ahead and find that GCF. 12 could be 1 and 12, 2 and 6, or 3 and 4. 15 could be 1 and 15, or 3 and 5. But remember, we have that negative, so there's actually kind of a double of both. One where the 1 is negative, and one where the 15 is negative, and then one where the 3 is negative, but one last factorization where the 5 is negative. And then we're going to go ahead and circle our GCF again, like usual. I do see a 1, but that's pretty small. Don't see a 12, don't see a 2, no 6, but there is a positive 3. That's going to be our GCF for this example. And now instead of setting up our box method, we're going to set up kind of those blanks, just like part C, B and C, sorry, just to show it algebraically. So I'm going to have my GCF, which is 3, and we need to figure out what times 3 will get us to that 12x. If we look back here, we used a 4, and we can't forget our x. Okay, this is our 12x from the original. And then we still have that plus a negative 15. So now we have to break up that 15 using our GCF again. And the other factor that we found, negative 5. And as you guys can see, that looks like step B. Okay, we have our GCF 2 times, and then we have our other factors. We've broken down the 12x into pieces and broken down the negative 15 into pieces. So now I'm going to do one last step, just like step C, and kind of combine these terms here. So 3 and 3, those are the same GCF. We can put those on the outside of our parentheses to be distributed later if we need to. And our 4x minus 5, or plus a negative 5, turn into our new binomial. This would be the binomial that originally would have been at the top of our area model, but we're going to start practicing this way to kind of make things faster. Okay, as we get better and we practice, we don't need to draw that box method, and we don't need to copy over that 12x minus 15. Eventually, we're going to learn how to get straight from the answer to this step C without all of the rest of these steps. Okay, using our calculator to help us out and just getting faster at this process. So let's go ahead and do the same thing for B. I'm going to change this to a plus negative, just so it's super clear which coefficients and constants I'm using. 2 and a negative 18. And I'm also going to go ahead and just draw a line here and copy over that original binomial that they're starting us with. Take a second, find our factors for 2, and then see if those factors also work for negative 18. So you remember 2 only has one factorization. And then instead of writing all 6 that we could have for a negative 18, we really only need 2 of them. 1 times negative 18 to match this 1 in case we need it. Or we can test out if 2 works, and it does with a negative 9. As soon as we know that that 2 works, we can say that's our GCF because it is the only other factor other than 1. And when I start creating that new expression That's where my GCF goes twice. We figure out what the other term is needed to get to 2n. And we could say that's 1n. And then we have to figure out what term we need to multiply to get to a negative 18. And we can say that's our negative 9. And if I rewrite it one more time using step C, my 2's are the same, that's my GCF, and my n plus a negative 9 or n minus 9, they're going to be the same thing, would go there. Now I have my product of a GCF and a new binomial. So we're still doing the same math as our area models. Okay, we're still filling in blanks. We just write it a little bit differently as we practice. So I'm going to go ahead and show us C and then D here. This time, I'm not going to write down all of my steps. I'm going to show you how it works just using that step C to find our final answer. We always need our GCF first, so I can do that either on paper or in my calculator. $24 could be a 1 and 24. It could be a 2 and 12. 3 and 8, or 4 and 6. $36 could be a 1 and 36. 2 and 18. 3 and 12. Let's see. 4 and 9. And if we can already kind of realize that we may not need all of these, just get as many as you do need. We could also have 6 and 6 here. But if you've already noticed that they have a pretty big number in common, for example, this one will be 12. And your numbers just keep getting smaller as you go. You could actually stop at that 3 times 12. Once you have that pretty big number, our GCF, you may not need to write down all of them. And so here's how I'm going to skip right to that step C. Instead of rewriting my original again, I'm just going to put an equal sign. Okay, we know that 24y plus that 36 is going to equal the new expression that I use. Instead of doing step B, where I actually keep them in 2 separate parts, I'm just going to skip right to step C. Okay, I need that space where I put my GCF, which is 12. And then I need my set of parentheses, adding in the middle, and I know I'm going to have a y on the first term. That's coming from my original binomial. The only thing that's left to do is fill in those other factors. 12 had to be multiplied by 2 to get to 24. 2 goes first. 12 had to be multiplied by 3 to get the 36. So the 3 goes next, and we're done. I'm going to show that one last time with part D. I'm going to let you guys finish the rest of this lesson independently. Here, this one should be a little bit quicker because we have 9 and 45. Okay. 9 only has a few factors, 1 and 9, or actually 3 and 3. It's a perfect square. 45 uses some of those same factors. We could say 1 in 45, but that I don't think will be our answer there. We could say 3 and 15. And we could say 9 and 5. Double check which one is our biggest common factor that they share. And then we're going to go ahead and write that answer. GCF goes on the left of our parentheses, the outside. We needed a 1 to get to 9, so it's going to be a 1z, can't forget that variable. And then we needed a 5 to get to our 45. Okay, 9 times the 5, if I were to distribute back out, would get me that constant 45. Then we're done with that one. So we're going to go ahead and use the rest of our time today to try out some practice. There are quite a few on this page, so you may not get through all of them, but there is a line for the GCF. Okay, so use your side of the screen here or scrap paper to write out those factorizations, find the GCF if you need to, and then you're going to write your factored form by kind of filling in the blanks, just like we did step C. You need your GCF on the outside, and then your 2 terms on the inside. Don't forget your variable. Okay. Some of these, as you get down to D, E, and F, G, H, and I, have multiple variables. Okay, if that's the case, you're going to do the same exact process, but then you would just have 2 variables on your answer. For example, D here, I'd still have my GCF on the outside. I'd have one other factor with a W on it. And then my very last factor would have that L on it. Okay. Don't get confused by those variables. Just make sure you add them on in your answer. Try the exit ticket as well, creating your own expression. Make sure you answer the self-reflection. And then the very last activity for today is to complete independent practice 29 back on Canvas. And you guys are done.